We're drawing a section through a suspended timber floor that meets a solid concrete ground floor. An example of this would be in the woodwork where the main floor area is timber, and then you go into the machines area that has a lino finish that's on top of a solid concrete floor. So the example that's given here is we've got a kitchen that's solid concrete floor with a 20mm tile finish, and then we walk into the dining room, and that is a hollow floor, so it's a suspended timber floor, 20mm timber floor, hardwood timber floor on top of timber joists. It says then both floors are highly insulated, so we'll show that in the drawing. It has to be done at a scale of 1:10, and we have to show both the foundation, the concrete ground floor, and suspended timber floor. And then part B of the question is we have to show how we get ventilation to the timber floor, because the timber floor will rot if we don't get ventilation into it. So starting off the drawing then, I've put in the external wall, just 10mm, 15 and 10 for our external wall. Our foundation then, I've just stepped out 35mm each side of the external wall, and the foundation will be 35mm thick. What I'm drawing in is a 350mm external wall, and that makes the real life version of the foundation 1050mm by 350mm thick. We have our ordinary concrete ground floor. So I've got 75mm floor screed, which is 7.5mm. I've got 150mm of insulation, so that's 15mm, and I've got 200mm of a subfloor, which is 20mm. You need to show then about 150mm wide here for the solid concrete ground floor. These are all construction lines. Don't draw these heavy, because we're going to have to do some changing here. We're going to have to put in vents and stuff like that in a while. So that is our solid concrete ground floor. We'll get on to the suspended timber floor part then. Okay, we have a model of suspended timber floor here that's going to help us explain it. So down the bottom we have our subfloor. Up on top of the subfloor we have what are called our rising walls. So these get us up to floor level. We build up walls. They're normally built out of brick or blocks, but the important thing when you look in at them is that they've got gaps in between them, so there's holes in them. So this is called a honeycombed rising wall. The idea of that is that air can pass through the wall. So we said we need ventilation in the floor. This is going to help with that ventilation. Up on top of the wall then we have a damp proof course, so that will stop any dampness that comes up through the blocks getting into the timber and rotting the timber. And then up on top of that we have our wall plate. On top of the wall plates then we have our joists fixed onto it. So that is our setup that we're going to be drawing, and when we draw it in, we're going to be looking in this direction here, so in a kind of an end view when we look in it. So when I look in through the section, I'm going to see my subfloor, I'm going to see my rising wall, damp proof course, wall plate, and then up into my joist, and that's what we're going to be drawing in. We're going to work from the top down then. So I've got my finished floor level put in for the time being. It said there's a 20mm hardwood floor in, so I'm just going to measure up 2mm and put in my floor. So there's my timber floor, is the first thing I'm going to draw in. And the reason we're starting from the top down is we want to match up both floor levels. We have our joist underneath, so we've got a 225 joist. So when I come down, I'm going to come down 225mm, 22.5 or 22 for our joists. And again, these are all construction lines. I'm going to set in 100mm for my wall plate, sorry, 75mm for the wall plate, 7.5. So 7.5 for the wall plate, and under that we'll have the rising walls. I'm going to draw in my joist here, so one joist here and wall plate, and then we're going to put a span in of maybe 1.5 meters and draw in a second joist and wall. I've drawn in the 20mm floor, 225 floor joists, and then we have our wall plate, so 75 high by 100mm wide wall plate. There's two of them put in. That allows me then to drop in the rising walls. So the rising walls are just set in here. There's no set height for these, so it'll depend on the building. So you can come down whatever distance you want, maybe 30-40mm, and then we'll set in our subfloor. So subfloor will come in, and again the subfloor will be 200mm thick, so 20mm. Now I've got my subfloor here in the first part of the drawing, and subfloor here in the second part of the drawing, and we need to connect those two together. So we're basically just going to draw a line to join the two together. we need to maintain the thickness, so I'm going to come back here 20 millimeters. So I'm measuring out 20 here, and it's just going to help me maintain the thickness. So this will be one solid floor when I draw it in. So what I have now is this kind of Z shape, and I'll darken that in so you can see it better. So I've drawn in the shape of the subfloor here. I've left a little bit of this light and a little bit of this light. That is because we have to put in ventilation, as it said in the question. I need to put in a pipe that's going to run from the outside in through the subfloor and in here. And you're going to let air right in through the solid floor and then into the suspended floor. So there needs to be a fall out the way on it to stop any rainwater getting in and flooding the floor. So my pipe is going to be drawn in at a slight angle. Standard pipe would be 100 millimeters thick. So I'll just come parallel to that, copy that angle. Angle doesn't matter once it falls out the way, so it needs to fall out towards the outside of the building, and that is my pipe drawn in. Now it's unfortunate where I put my two symbols because they're right in the middle of the pipe. Get rid of those. So now I've got my subfloor in, ventilation going in through it, and here is my finished subfloor. I'll darken in the insulation, the floor, and now I can darken in all my foundation, and then we'll finish off the drawing. Okay, I've darkened in all the floor and the walls. I've put a vent onto the pipe just to stop any mice or insects or animals getting into it. We'll go finishing the detail on the drawing now. So at this stage we can put in our rising walls. So we've got the position of them put in. They're obviously directly underneath the wall plate. So these are our honeycombed walls, and they will let air in through them. We need to put in a damp-proof membrane. It could be put above the subfloor, but for this drawing we're going to put it underneath the subfloor. It just makes it a little bit easier to draw. So it comes along and it is going to continue under the entire subfloor. And right out through the wall. Okay, so that is the damp-proof membrane put in, and then it'll turn to damp-proof course when it goes out through the wall. We need to cushion that to stop it getting punctured, so we'll put in a thin layer of sand underneath it. So sand blinding under here. And then we have our hardcore under the rest of it. So we've got our layer of hardcore, and you can show that layer of hardcore being finished off anywhere. It doesn't really matter because there's no set thickness for hardcore. It just goes in 225 millimeters layers. So you put in a layer of hardcore and then you roll it and you put in another layer. That's that drawn in. We also need to put our damp-proof course under the wall plate. So up top up here, they need to be dropped in. So damp-proof course here, damp-proof course in there. It said both floors are highly insulated. So what that means is that we need to put insulation in between the joists up here. And again, we'll use our PIR insulation. So I'm going to come along and put in my symbol for the PIR insulation, and I'll colour it in with a little bit of yellow. The PIR insulation is put in between the joists, so that's fixed in place. I need to show my insulation here as well, and I need to show my outside floor level. Below the damp-proof course, so it has to be below the damp-proof course, I'm going to put in my concrete fill. So in other words, the rising walls, to stop them collapsing, need to have concrete filled in. Minimum 150 millimeters below floor level is where our ground level is. So down here is my outside ground level, and I can put that in anywhere. and I can put in maybe a concrete footpath just to show it outside. But again, it has to be a minimum 150 millimeters below the damp proof course, and again the vent has to be above that also. Last thing to do is just put in all my labels. Okay, so the drawing with labels, the important labels: your damp proof course, diameter 100 millimeter vent pipe. We've got our 20 mm tile that was outlined in the question, 75 mm screed, 150 millimeters of insulation, 200 millimeter subfloor. On the other side, we have our 20 millimeter timber floor, 225 by 44 joist, PIR insulation in between the joists, and then we have our 100 by 75 wall plate. We've got damp proof course again, we've got our honeycombed wall, we've got our damp proof membrane, and we've got our sand blinding. Final touch then is just I need to show the symbol for our block walls, and again they're built out of blocks or bricks, so we're just showing the symbol for block construction. That is the drawing complete.